So with that, I want to bring up the Sponge Park. This is again, it was sort of a self-initiated project. We started working with the local community group, and then we ended up sort of keep pushing on and getting grants and working with city council, and now working with an agency to kind of try to develop this whole idea. And it has sort of snowballed along the way, which is great because I think it's actually going to happen. But when we started the project, I thought, I can't go into Carroll Gardens or Cobble Hill and say I'm going to put a bunch of wetland in the backyard. It's an area where they don't necessarily even want trees. They're happy with paving because they just don't want maintenance, they don't want to worry about anything. So we came up with the idea of talking about how landscape spaces act as these absorbent surfaces. So everybody thought, oh, Sponge Park is some magic material, but it's just an absorbent landscape, with well-designed soils and really nice planting. It is a little more than that, but as you know. So we came up with the idea of the Iguanas Canal Sponge Park, and some of the initial funding again came from the New York State Council on the Arts. So this is that detail or that diagram in more detail. This is a diagram that's actually done by the EPA about how CSOs work with the issue of the raw sewage going into our harbors. In New York City, we have on average about 400 million gallons of combined sewer water or combined effluent going into the harbor every week. So, and the Gowanus Canal is a post-industrial waterfront, although it's actually still an industrial waterfront in a very limited way. It can be very beautiful, but it also does have this kind of degraded bulkhead and a lot of vacant space around it. And then also a number of uses that are not water dependent. It's a Verizon parking lot. And then some areas that are dependent on water, but aren't necessarily as useful or functional as they could be. This is the Gowanus Dredgers Boathouse. It's a canoe club, and they have their canoes and kayaks in that shipping container, and then they built this little access point. And we had an office field trip where we actually went out canoeing on the canal. But you can see that there is this major stormwater issue that we have. This was a fairly average storm in the area, and our streets really flood. And that flooding brings with it all of the oil and detritus that then collects at the street end. And here you can see also the impact of the CSO with basically like raw sewage floating on the top of the water. So we looked at the watershed and the sewer shed. It's interesting to sort of think about them being different because water doesn't always flow downhill in cities, or at least it was sort of funny to think about that initially. So we looked at the location of the pump station. There's actually a tunnel that runs from the East River into the Gowanus Canal that's supposed to flush fresh water through and make it a happier ecosystem. But that pumping station has actually been broken for a long time, so for like 20 or 30 years. So it's very sort of third world country kind of conditions in the canal. It's really, really dirty. And that is now being restored. So that's the location of the pump station. And then there are these CSO outlets and storm drains. So our idea was that these sponge parks could be used to process a lot of this stormwater to reduce the load on the combined sewer system. So we looked at the hydrology, the ecology, the land use, and the cultural preservation. We broke that down into the CSOs and street runoff, contaminated water leading to poor animal habitat. A number of spaces are privately owned, and there's a lack of maintenance. We looked at the sort of components of the waste and the problem, and then sort of thought about how that is leading to contaminated water, low water clarity, odors, surface water contamination, poor habitat, limited water access, and limited canal edge access, and this really deteriorated bulkhead. And then thought about how this sponge park could actually address all of those issues. Not as if by magic, but through a sort of long and incremental master plan that, will be in part done by us, but will potentially be done by a lot of designers working in the area and a lot of agencies working in the area. So we called upon, when we started the project, there weren't a lot of green infrastructure projects out there. This was a particularly smart one by landscape architect Kevin Robert Perry in Portland, Oregon. I'm sure that you've all, or being landscape architects, I think a lot of you have probably seen this. I think it's a really beautiful example. But we looked at places where this kind of operation might exist. You know, we went out and physically mapped where all the driveways were and the access points. And then we also looked at the idea of having a stormwater irrigation esplanade, having zones where more of the stormwater could be collected and used. So really, in an average rainfall, the filtration swales would collect most of the water, but then in a heavier rain, the water would actually be redirected into this edge condition. We looked at plant communities that could both process PCBs and withstand different amounts of rain, and even like sustained wetness. And then also looked at how different chemicals could be remediated by the plants, and showed images of what those might look like and how they would perform and how that would be sort of organized across the site. Again, it's a master plan, so it wasn't intended to be very specific in this case. We looked at these street-end sponge parks, the ideas for programming for community gardens, playgrounds, dog parks, neighborhood garden centers, and open-air markets. The idea of remediation, where that might happen and how, sidewalk stormwater filtration swales, floating remediation wetlands, street stormwater filtration swales, and other remediation wetlands. Idea of the esplanade, cafes, canopy, different materials, some impervious and some pervious to direct water and use it, planted edges, floating remediation wetlands, and views. It's a 1.8 mile long site, so we had some opportunities to do some different things. And then they're also, you know, looking at examples of like the Tate Modern for that decaying building that I showed you before, you know, turning it into a cultural complex, thinking about the industrial character and maybe using shipping containers for cafes. And then looking at the section and the different opportunities that exist within the section for really a layering of program over ecology. So, but I think you may remember from the diagram that I mentioned conflicting sites. There are a number of areas where you can't actually get to the water's edge. And so an idea developed about how the whole area becomes this urban promenade. It's not just about creating a different esplanade, it's about creating a whole kind of green district. So again, with the phasing, we spoke to developers who were working on the site and talked to them about how they could incorporate our ideas into their planning. And then looked at some other opportunities that might happen in the sort of midterm, and then a sort of longer-term vision of how the whole thing would operate all together. So as a view of the esplanade from Carroll Street, Sponge Park at Sackett Street, Sponge Park entrance at 3rd Street Bridge. And okay, so then we did all of that, and then in the middle of all that work, the Gowanus was declared an EPA Superfund. Fun, sure, right? Now what do we do? So it is a really dirty site. There was a lot of petroleum processing and manufacture happening on the site, and this red line shows the area of contamination. This is a densely urban site, and there are like playgrounds that exist right in the middle of this really contaminated zone. So we just kept going. We thought, you know what, this isn't going to stop us. All the development work stopped on the site. But we kept looking for ways to make it happen, and when this happened, the Department of Environmental Protection was also in the process of thinking about new green infrastructure systems and developing those for New York, and so we ended up partnering with them on a project. But before I go into that, pilot project, I want to talk about a little bit about the regulations. You know, not only do we have the EPA Superfund, even without that, it's really complicated working in the urban condition, as you know, because a lot of you are working with that here. But the sediment underneath the canal was controlled by the Army Corps of Engineers and is now controlled by the EPA Superfund. The The first 5 feet of sediment in the upland areas is controlled by the state entity, the Department of Environmental Conservation. And they also control shade over the water. The Parks Department handles all the plants. The DEP is handling all the water coming down the street, but the street is actually owned by the Department of Transportation, right? So then we also have access from the fire department for these street ends, because they're all dead-end streets. And then, who else? The Department of Sanitation has to weigh in. The Department of City Planning was sort of managing these new open space setbacks. So it was really this incredible kind of maze of organizations that had jurisdiction and also sort of some say in what we were doing. And I have to give great credit to the Bloomberg administration, because as we're working through this, prior to this project, I encountered a number of conditions where I'd be trying to sort of carry out Plan YC, and I'd have an agency say, well, no, I'm sorry, sorry, I know that's what we told you to do, but I just don't want to maintain it. I'd have the DOT say that, or I'd have the Parks Department say that. So the credit to the Bloomberg administration goes in establishing a memorandum of understanding between the Department of Transportation, Department of Environmental Protection, and the Parks Department to actually pursue these green infrastructure projects. And so the DEP is going to pay for long-term maintenance, but the Parks Department is going to do it, and the DOT is going to actually let them do it on their site. So, and lest you think that seems really simple and straightforward, each of these agencies actually exists under separate deputy mayors, and they have separate funding streams. So it was complicated, but they're doing it. So this project has actually been sort of folded into that idea. But in order to get buy-in from all of these different entities, I probably had 50 or 60 individual conversations with people. I didn't say, hey, let's all get in the room and talk about this, because that just wouldn't have worked at all. So there were a number of sort of very specific conversations where I just talked to people about how it was a good idea, and I also talked to them about how it might save money. And that's always a good thing to propose. So this is through a grant from City Council, or actually an appropriation or an allocation from City Council. This time it was de Blasio and David Yaski. They sent money for construction to the Department of Environmental Protection to build a first pilot project for the Sponge Park. Nydia Velasquez also got her first interiors appropriation for the Sponge Park as well. But none of that money was for design. And so DLAND applied for a grant from the New England Interstate Water Pollution Control Commission to pay for all of our design fees to actually make this a reality. So we have our design team of DLAND, Weidlinger Engineering, Montclair State, CUP, the Center for Urban Pedagogy in New York, the Education Partner, and the Conservancy. So we calculated we needed to figure out where to work. So we calculated the amount of water in the street ends and decided that 2nd Street was the best pilot because it had the most water going down the street. And then we looked at sort of the catchment area and defined it much more specifically. And then looked at how much water would actually be processed by the street swales, and then how much could go into our sponge park at the street end. I looked at the area where we could operate. As I said, there was this new 40-foot setback from the bulkhead edge, and then a 10-foot supplemental public walkway. So we're trying to operate only in the public realm. And then also that was actually helped by the fact that Toll Brothers was actually going to build this big development on this area, and they had done a rezoning of the site. There's a rezoning happening of the whole district, and it stopped when the Superfund happened. But this developer had already done a special district, so we had this special setback already. So this is our existing condition. We have the cobble streets, and these are Parks Department green streets. And this is our vision of what it could look like, our project area. So we had an issue of those cobbles that you saw. There's an art commission in New York City that's very sensitive about the removal of cobbles in the street. They see them as a very important historic resource. So we mapped where cobble existed in the street ends throughout the Gowanus area, the typical street ends. And then showed sort of the allocation of materials, or the distribution of materials, and then also showed, when these materials were put in place, that cobblestones were used between 1830 and 1860, that the Iguanas Canal was finished in 1869, that road asphalt was invented in 1872, and then there were planters and concrete and brick that were put in the 2000s. And then we showed them our existing conditions and how we're really just redistributing the materials within that existing condition. And that was really important for the Art Commission. And they can be, it's sort of one of those entities that all the agencies fear in New York City, because it can really hold your project back if they don't give you approval. So this is the removal of the green streets, thank you, the putting in of the street swale, putting in the bioretention cells in a modular system. And then we have an integrated sidewalk and sedimentation basin. So it's a basin that's topped with a stainless steel screen that you can walk upon. And here we have a pedestrian path with an integrated sand filter below it. So again, it's access to the waterfront. And then we have a drain. The dredger boathouse is actually right here. So we need to maintain this. So then it rains, and the water goes into the street swale. And it keeps raining, overflows, goes down the street into the sponge park, fills up the sedimentation basin, and then the water flows into the planters, basically. And then the plants, actually, the soil and the plants absorb that water. But then, if it rains a lot, it fills up again, and then it'll overflow into this sedimentation basin, into this sand filter. And then that water can actually go into the Gowanus. Susan, can you make it go to the next slide? Oh, it just went. Great. Okay. Last night I had trouble with that. So here is an image of what that might look like. We're turning what was just a street end into a new kind of public space. So now I want to talk about the pop-up park. This is a temporary open space that we created in 5 weeks for the Brooklyn Bridge Park Conservancy. Basically, this is the site of Brooklyn Bridge Park, where Michael Van Valkenburg has done that incredible open space. But before that started construction, the Ulfer Eliasson's waterfalls were being installed, and the Conservancy said, hey, you know what, we got to be able to get people down here. There was a lot of fatigue, sort of planning fatigue. The Brooklyn Bridge Park was about 30 years in the making, and people felt like it was never going to happen. And so the Conservancy just felt like they needed to get people down on site. They wanted to just put down a big sea of sod. We said, no, I don't think that's going to work. So we basically begged, borrowed, and stole, and managed to put together this park in about 5 weeks. We were given the parameters of well, we really can only pay for asphalt. It was $100,000. We had a $100,000 budget, and it's about an acre of space. So I called the surfacing company and got them to donate paint so that we'd have a higher albedo surface, so that it would be, say, 85 degrees down there in the summer instead of 125 degrees. And we included grass, but we made the grass a sort of special element that you could lay on and hang out on, not a surface that you'd walk on and destroy. And then we had a lot of donated materials, like the park benches that we distributed around the site that were owned by they're actually owned by the Conservancy, so we put those in place. And then we took a siltation barrier that was existing and planted it with sedums. So, it's really, and then put in this sandbox for kids. We also, very inexpensively, designed a scavenger hunt for the kids. We came up with this whole nautical theme. Here you can see one of the little stencils, and we had this card that you could pick up there was a bar and a restaurant that existed within, or that we put in an old shipping container. And at the bar, we had these little cards, so you could, as the parent, you could bring your kids down and you could get a glass of wine and give your kid the card, and you could run around and play, and you could sort of enjoy the beauty of the waterfront and the sculptures, and sort of have a little quiet time for an adult conversation, or even enjoy the fireworks. So, and we had 200,000 visitors to this space in, I think it was open for 12 weeks. So I see it as a pretty successful kind of pop-up open space. I think we were the first ones to actually use the term pop-up park. And that was, and I have to give credit to architect Chad Smith, because he was the one that came up with that idea. He said, oh, you made a pop-up park, that's so great. There's more images of what that looks like. Now, I want to talk about this next project. The idea here is that we were thinking about how stormwater is working in the city, and how you have all these raised highways that exist all around the country, actually, and how we might make a sort of modular wetland system to manage those flows off those raised highways. So we have our project site, the Flushing Sponge Swale, really near the site of the Old World's Fair. We have these elevated highways that deposit stormwater runoff into the Flushing Creek. And here you can see a sort of typical condition of this downspout and this concrete pad and this drain. And those road pollutants from cars and surface sediment include heavy metals, oil, and grease. So we can actually use this landscape to not only soak up some of the water to keep it out of the CSOs, but also to clean it before it goes into the water. As I said, we're on the site of the Old World's Fair, and the water from these two lakes is actually going through our site out into Flushing Bay, so into the harbor. These are our two sites, and you can see there's sort of this grassy area, and a lot of times the drains actually overflow and the water just goes across the road. We mapped the sun angles to find the sort of most ideal position for these swales in each condition. And really the idea is that you'd slow down the water, you'd capture the sediment and floatables, you'd evenly distribute the water, and then you remediate it, and then you'd have it overflow into the Flushing Creek. So with this was a project we did through a grant from the DEP, again a grant. So what we're doing is trying 3 different methodologies, and what I want to do is actually come up with a system that could be mass-produced and used in other municipalities. And just, since you're all, a lot of you are designers, one of the things that was sort of a big issue for me going into this was that I own the intellectual property, and that's not really a normal thing for the city of New York to actually give designers the rights to their intellectual property. And so I managed to actually secure that because I didn't really think that they needed it beyond what they were doing in the city. I felt that Mayor Bloomberg should be able to go to the city of Philadelphia and say, oh, here, we have this idea that we're using and it's working, and why don't you use our technology? Because I thought, what, we're designers and we come up with these ideas, and there's a lot of value in that. And I don't think that architects and landscape architects always value their ideas as much as those ideas are valued in other professions. So So anyway, so we developed 3 different kinds of systems. This first one is kind of what I imagined initially was sort of a cell that would include this sedimentation barrier and a concrete basin that would manage the water. And it just has very specially designed soils for a certain level of infiltration. And go through these stormwater swales. This one we're doing something slightly different. We're actually having the water come down over kind of a caged gravel area, and then having these planting beds work within this kind of field. This one may be really good for educational purposes. We're going to work with the New York, there's a science museum on the site, So we want to bring kids down to look at it. I mean, the way it was designed was really to distribute the water evenly, but I think that it may end up being a good sort of teaching system as well. So in this case, it's a little bit more shallow, and we have this water distribution over a sort of broader plane. And you can see what that one looks like. It's a lower profile. And then this final typology, we had to do a planter that was above ground because we had a really high water table in this area. So in this case, the water is actually flowing over the surface, and then this is a much more shallow basin that absorbs the water. We'll be monitoring these systems for 3 years to find out sort of how much water is running through the system, at what rate, and how clean it is when it enters, and how clean it is when it, or how dirty it is when it enters, and how clean it is when it exits. So we've looked at plant communities that can help with hydrocarbon degradation and also heavy metal accumulation, and that are also stormwater tolerant, and then trying to design for kind of seasonal interest. So now this final project is actually a design competition we did for the UNESCO Design Challenge, and we won. But it was creating a better link between the airport in Montreal and the center of the city. And our project is called Infrasutures. So Montreal is really a city divided. It's wounded by the infrastructure systems that run through it. There are existing water systems that are really sublimated to the urban structure, and the habitat is really fragmented. So we have divided neighborhoods. And the idea with infrasutures is that through energy production, urbanity, habitat, and water, we can use these elements to kind of stitch the city back together. So we looked specifically, or sort of in more detail, at certain areas along the site, and thought about how we might do this stitching through transit and habitat, filtering the water, sort of bringing out the escarpment ecology, remediating the rail areas, connecting certain communities, restitching and cleaning the water. How we might develop a whole system of green streets and blue streets, expand a canal area, and then use wetlands to remediate. And also how we might sort of augment the urbanism, revitalize the Cabot area, connect the upper Lachine Street, densify the canal, and expand the St. Pierre neighborhood. And then how energy and production might actually be folded into that with geothermal fuels and vertical industry.